Okay, let's take a look at a few different examples of factoring. All right, in the first example, two terms. As always, the very first thing, two terms, three terms, or whatever, look for a common factor. So obviously we see 7 is common. Okay, they both have x. The lowest power of x is x squared. That's pulled out as a common factor. Two terms have to come back in here. 7x squared into 7x to the fourth goes x squared times. Okay, 7x squared into 14x squared goes 2. Done. Nothing further. This does not factor. Move on. Number 2. Difference of two terms. Difference of two squares. 81, perfect square. Square root 9. 256, 16 squared. C to the fourth breaks down to c squared, and c squared, y to the fourth. Y squared. Okay? So therefore, this is a difference of perfect squares. It goes into two groups, one with a plus, one with a minus. The square root of each goes in to each of the terms. Square root here, 9c squared plus 16y squared. Same thing over here, minus sign. 9c squared minus 16y squared. Factor? Yes. Factor completely? No. Why? Because here, again, lies a difference of squares. That, again, can be factored. So we factor it. 3c minus 4y, 3c plus 4y. This don't forget to bring down. It will not factor again. Don't make that mistake. It only factors here because it's a difference of squares. There's no technique for the sum of squares. Therefore, only this refactors, this stays. This is a two-stage factoring problem. This was a problem we looked at on the slideshow. It's worth looking at again. Okay? You say, well, I don't know. It doesn't seem to be anything apparently to be common. Don't even go there about expanding that out. That's just making things more complicated. The idea about factoring is to make things look a little bit more compact. Factors means they're multiples, okay? Don't expand that out, okay? It's doing more work than is necessary. You'll say, well, this is x minus a, this is x plus a. Why couldn't it say x minus a? Well, in fact, it does. In fact, it does, because if you look at just this cluster right here as a group, you can say, well, if I pulled out the minus sign as a common factor, then this could read x minus a. There you go. And this is 64 x minus a to the fourth power. Now you might say, well, gee, I wish it looked a little bit more user-friendly. Well, there's no problem. Let's do that. Let's do a substitution. I'll do a little bit of sidebar over here. I simply say, okay, I'm going to let, I'm sorry, we can come back to that. I'm going to let my x minus a expression, put it up here, x minus a is now going to be called y or u or p, whatever. So now it reads 64 y to the fourth minus, okay, minus y. Well, now we identify a common factor. If you identified it up here, fine. Didn't have to do the substitution. We pull out the y as a common factor. We got 64y cubed. Sorry, 64y cubed minus 1. No, you're not finished factoring. Okay? Not finished factoring. Why? Because this is a difference of cubes. Oh, 64 is 4 cubed. Okay? So now we have to recall our factoring technique for cubes. Okay, give myself a little bit more space. Come back and erase that. Okay, remember the factoring technique for for cubes, difference of cubes. It's, okay, if you had something looking like a cubed minus b cubed, it factors into a minus b, SOAP, same sign as the first group, and a squared, okay, opposite, same opposite, always positive, plus a single AB term plus a B squared term. Go back to the slideshow review we had on that, okay? Well, in this case, B is like the 1, and A would have to be like 4Y. So, okay, here we got Y coming out. We got 4Y minus 1, okay? And then we have the 4y collectively being squared, that's 16y squared, okay, plus 4y plus 1. But let's recall, the original problem did not have a y, okay? So now we have to return that original y, which was this x minus a expression. X minus a comes back. Use brackets perhaps, 4 x minus a minus 1, and we got again we have, it's going to get a little crowded here, okay, 16 x minus a, and plus that's squared, that's collectively squared, plus 4 x minus a plus 1. Now, that is now factored. You may not like its appearance, okay? Depending upon where we're going with the problem from here, you may think, well, you know, maybe I want to distribute that. Maybe I want to expand on that. It's fine for now, okay? The objective behind this problem was to show you what some substitutions could do for you to make things look a little bit more user-friendly, so you could identify forms, okay, and apply the particular form as we did with the difference of cubes, and then do the substitution. Okay, let's do one last example here. A trinomial, as always, any factoring, you want to look for the common factor. Obviously, there's a 2 that can be removed, okay, giving us 3x squared, okay, minus 1x minus 10. We can do that method as demonstrated on the slideshow, or we could do the trial and error. Let's try the trial and error here. Mainly because, you know, we got a prime number here with 3, so there's only factors of 3x and 1x in these locations. Again, we're after negative 1x here. 10, 5 and 2 perhaps, okay? 5 over here would collectively give me a 15. That would be too big. Let me try the 5 here and the 2 over there. Now, this would give me 5x. This would give me 6x, okay? If the 6 were negative, okay, remember, this minus sign says we're going to have a plus and a minus. I'm not sure which one's getting which, but, you know, I'm testing it out right now, okay? I'm going to go here with the minus and here with the plus, and I'm going to check this because I just want to make sure. So this collectively inside, remember the FOIL method, first, outer, inner, last. Well, we're only interested in the outer and inner, because if we can get the outer and inner and pull this term back, then we're in good shape. So that's a 5x right there from the inner 2. And the outer 2 is a negative 6x. So there's a negative 1x. We won overall. That's good. Okay, that's what we had up here. So now this is factored. Okay, so this expression, 6x squared minus 2x minus 20, factors with a common factor of 2 coming out, 3x plus 5, x minus 2. Now it's factored completely. These should not have been overly difficult. Okay, this number 3 is a little bit challenging, but and the idea there is just, again, to recognize a form over here. In both 2 and 4 here, the issue is multiple tiers of factoring. Just because you're factoring once doesn't mean you can't factor again. But as is the case over here, doesn't mean you have to factor again either. So there's your review of some factoring problems.